Hello and welcome to the first 5 videos about logistic regression. So logistic regression differs from multiple linear regression sort of in one key way. There's actually lots of ways in which it differs, but sort of in one key way that we're interested in for building our model, which is the outcome variable. So previously we've been using continuous outcome variables, so we've been using the explanatory variables to try and predict where an individual case will lie along a particular scale, an outcome measure. In the case of logistic regression, our outcome measure is actually binary. So there's that which means that there's only two possible categories that an individual can fall into. So we're actually looking at the probability of a particular case falling into one category over another based on the explanatory variables, which are used to sort of calculate this probability. So we're fitting a model to the data which can best classify cases based on explanatory variables. So we're going to be running through the same example that we do on the main website. So if you want to go through things at a different pace or look at certain elements of this model in greater detail, then you can do over on the main site. The outcome variable we're going to use is this one here, 5M. Now 5M basically is a measure of whether or not students successfully achieve 5 passes with A star to C grades or more at GCSEs, which is at age 16. Including English and Maths, and that's actually quite an important benchmark of educational success in England. Universities tend to look at that when they decide what students to enrol, and I think employers tend to look at that as well. So it's quite an important benchmark of success. And as you can see, the variable, we've just moved to the variable view from the data view down there. The variable itself is actually very simply coded. It's 0 for no and 1 for yes. So 0, they do achieve they fail to achieve 5 A star to C grades, including English and Maths, and 1, they do achieve those 5 or more, including English and Maths. So it's quite a good example of an outcome variable, because it's obviously it's definitely an outcome, it's an educational outcome, but at the same time it can be simply coded into a binary response. So it's very good for use within the context of a logistic regression analysis. So let's now run through the process of doing the actual regression itself on SPSS. As usual, we go to our trusty Analyze button, down to Regression, and then to Binary Logistic. We get this window here. You'll notice that what used to be called independent variables has actually been renamed covariates here, which seems to be just to confuse people, but you just have to look out for things like this. There are a few quirks with SPSS with it renaming things between different tests. But as usual, we want to put our outcome variable in the dependent box, and our outcome variable is 5M, so we'll put that over there, and we put our explanatory variables in this covariates box. For this model, we're going to include ethnicity, social and economic class, and gender. So if I can remember my alphabet, I'll add all of those. You'll notice that we're not including any continuous explanatory variables. That's not because you can't. You can just as easily include continuous variables as explanatory variables as you can with multiple linear regression. But it just so happens that we're not going to for this particular one. So I've lost track of what I'm doing. I need to add SEC and gender. So there are 3 explanatory variables there. Now at the moment, SPSS doesn't actually know that they're categorical, and we need to use this button here to tell SPSS that. So it opens another little pop-up, and we actually need to, in this case, pull them all across into this categorical covariates window. Like I say, we don't actually need to, it wouldn't be the case that we'd always pull all of them across. It would just depend which of them weren't continuous. In this case, we don't have any continuous explanatory variables. Now, one of the things that SPSS does do, which is very kind, which it didn't do for multiple linear regressions, it actually creates all the dummy variables for you. Remember, before we needed to create a dummy, basically we had one baseline category for each categorical variable, and then we had to create a dummy variable for each of those other categories in order to compare directly to the baseline category. Now, luckily for logistic regression, and I don't know why it does this for logistic regression but not for multiple linear regression, but for logistic regression SPSS will do all of that for you. All you need to do is tell it what you want the baseline category to be, so what you want the comparator category to be. So as before, I think we'll use, for ethnicity, it's best to probably use the the ethnic group which is most common, which is white British. Now they're coded, white British students are coded as 0 in our data set, which is obviously that's the first category. So we just need to do one little change here, which is for ethnicity, move this radio button to first and click change, and you'll see that first appears here. So that's just telling SPSS that, okay, the reference category for each dummy variable is white British, and all the other ethnic groups will be compared against the white British category. For SEC, we don't actually need to make this change because the default is to set it to the last category as the reference, and that's right because we've coded it such that 1 is the most affluent social economic class and 8 is the least affluent. So all our comparisons will be between the least affluent and each of the other social economic classes for this model. Gender, we actually want to put it as first again, because we've tended to compare, it doesn't really matter, but we've tended to compare boys to girls throughout, such with boys being the reference category, to sort of see the change between the change in outcome between being a boy and being a girl. And because boys are coded as 0, which is first, and girls are coded as 1, we'll change this one too. So just make sure that we've got in this window here ethnicity as first for the reference category, SEC just stays the same, and gender is first too. And then we can just click continue, and you'll notice that although it doesn't tell us what the reference groups are, it's put cat next to each of these 3 variables, just to remind us that we have already told SPSS that those are categorical variables. Okay, so there's some other options that we can look at. There's the save options. You can actually, as before, you can get residuals from logistic regression. They're slightly different because obviously we don't, the outcome is always 0 or 1, but what we're actually looking for is the difference between the probability that the model uses to make its predicted classification and the actual classification. So let me try and explain that in a slightly less confusing way. So if you're coded as achieving 5M, you'll be given a 1, but the model will calculate a probability for a given case of achieving 1, and if that probability is less than 0.5, sorry, if that probability is less than 0.5, they'll classify the case as a not achieving 5M, but if it is higher than 0.5, it'll classify it as achieving 5M. Now, say you got a particular case had only a point, according to the model, had only a 0.35 probability, say, of achieving 5M, but actually did, then you'd get quite a high residual. You'd get a residual of 0.65. So there'd be a difference between the 0.35 prediction and the 1 that actually came out of the model. So you can still measure error using those probabilities compared to the outcome. We're not going to include any in this particular example, but it's really useful to know. So you could, for example, just get the standardized residuals, which, as we know, is something that's quite useful when exploring how successful your model has been. And again, you can look for things like Cook's distance. You can calculate that for each individual case, which is very, very useful to look for any sort of particularly influential cases. Again, we're not going to go through this in this particular video. We will do later. And finally, you've got predicted values. So again, these probabilities, which I spoke about, which are used to calculate the residuals, and also predicted group membership. So you can see how many times the model misclassifies the data, if you like. So the actual data will be compared to the model to see how well the overall model fits the data later on. But it's quite useful to be able to see the sort of percentage of correct classifications, if you like. We won't include any this time because we'll come to that in a later video, but it's just good to run through these option menus and see that they're there. Options, again, there's something very useful called a classification plot, so we'll have that, and that is basically looking at the amount of times the model does misclassify the data, but it shows it in a quite useful graphical form. There's the Hosmer and Lemshow goodness of fit test, which is a good way to testing whether your model is actually a good fit for the data. And you can also get confidence intervals, which we've spoken about before, for the EXPB is the odds ratios. So you can get a range of values for which you're 95% confident that the real odds ratio will lie within. So that again is quite useful to get. So we will request those 3, and then we can click continue. And I think that's everything, so we can just click OK to run our model.